Prehistoric Cultures. This lecture is intended as prologue and background to the study of civilization as it is known to us through historical records. Since the evidence of human experience prior to recorded history is rather limited, what we can learn from this long period of evolution and development is mostly speculative and uncertain. The issues are further complicated by the split I perceive between the archaeological work of skeptical scientists and the psychic intuitions of clairvoyants. The two groups discuss human prehistory from such different philosophical premises and perspectives that they hardly seem to be aware of each other's theories and consequently rarely communicate with each other. The scientists search for all the physical evidence they can find and attempt to devise theories from the geological and biological records and the few human artifacts that are discovered. The clairvoyants search within the spiritual realms for the soul records and then try to describe the consciousness they have perceived inwardly. The most apparent links between these vastly different worldviews seem to be the myths and legends passed down to ancient peoples, which can be found in some historical writings and art, and which point to some of the more far-out ideas of the psychics. Scholars discount most of these as imaginative flights of fancy. But what is imagination, and where does it come from? The spiritual side points to the mystery of creation and the miracle of consciousness as evidence that we are spiritual beings who transcend physical bodies. The traditional science can theorize about the creation and evolution of the universe, but cannot really explain why the universe was created, by whom or what, nor for what purpose. Nor does it know how or why consciousness was created, or even what it actually is. That which occurs in the spiritual consciousness without making its imprint in the physical realm obviously will not leave any evidence for those who only consider the material facts. Yet, that which is perceived or imagined through psychic means is difficult to verify, and psychic distortion occurs rather easily. Where psychics disagree, the results must be treated as speculation that may be true or false. But where there is broad agreement from many clairvoyants with good records in other areas of psychic perception, and particularly when ancient myths or modern scientific theory can corroborate their testimony, then I believe we ought to take their ideas seriously. What I will do in this lecture is to present both viewpoints briefly in an attempt to develop a synthesis, which I believe could be true from both perspectives. You are warned that this lecture is the most speculative and uncertain in this whole series, and I hope that possible biases will not prevent anyone from going on to appreciate the rest of this series, which is quite different from this particular lecture. However, three fundamental questions of our origins may give us a helpful background. These fundamental questions of our origins may give us a helpful background to the natural laws and principles which later became a context for human ethics and civilization. Evolution of life. From the spiritual perspective, the universe is usually considered to have been created by God, with spirit pervading the entire universe while at the same time transcending the physical in other realms of reality often referred to as heaven. We will be exploring and evaluating the views of the various religions and philosophies on these points as we progress through the work. For now, let us move on to a brief description of the generally accepted scientific theories on the physical and biological evolution of our world. The explanation of evolution does not contradict the spiritual perspective unless one takes literally certain ancient myths that became scripture for some religions. Currently, the most popular theory is that this physical universe originated in a tremendous explosion called the Big Bang, which created in an instant all of the energy matter which remains constant in this universe. This beginning, which from the spiritual view could have been preceded by other events, universes, etc., probably occurred about 13 to 20 billion years ago, although there is a recent theory that it could have been much less than that. How the galaxies, stars, and planets were formed is not precisely known, although gravity is what holds them together. The atomic structures of the chemical elements were formed in the intense heat and interactions within the early galaxies. Some say that there was a split between matter and antimatter into equal and opposite portions. The physical universe is still expanding, and it is not known whether it will continue to expand indefinitely or whether the pull of gravity will cause it to begin to contract, eventually to collapse back into itself. Black holes are very intense gravitational fields which trap all energy matter nearby, even light. Recent evidence indicates that there may be a black hole at the center of our Milky Way galaxy. Spiritual theories suggest that these black holes may be doors to other parts of the universe, or even to other universes. The first law of thermodynamics is that energy matter in this physical universe remains constant. The second law of thermodynamics, briefly stated, is that entropy always increases. To explain it more fully, in the process of using matter and energy in space and time, some energy is always being lost as heat. For example, when organisms take in nourishment, they are able to use it in keeping their bodies orderly and functioning. But the total amount of order in the universe actually decreases as some of that energy always escapes as the less orderly energy of heat. Our sun is about 7 billion years old, and this Earth was formed approximately 4.7 billion years ago. The center of the Earth is packed into a solid inner core, which is surrounded by a liquid outer core. This is enclosed in a thick mantle, which is covered by the crust. The coming together of the particles by the force of gravity caused heat and melting. This heat was supplemented by the radioactive decay of uranium. The heavier molten materials gravitated to the center, while the waters and air of the hydrosphere and atmosphere may have condensed from volcanic emission of gases. The rocky crust formed into continental land masses, while water filled in the oceans over their constantly churning floors. Although continental ages go back almost 4 billion years, their shapes have changed many times. As the Earth cooled, heat was released vertically through volcanoes. The great continents and oceans consolidated themselves about 3 billion years ago. The one continent of Earth, called Pangaea, probably began breaking up about 200 million years ago to separate gradually into our modern continents. The sea, as a reservoir of heat and cold, acts as a global thermostat to moderate temperatures on the Earth's surface. The spirit of the Earth was named Gaia by the Greeks, and as a whole, it possesses many of the characteristics of a living organism. The original atmosphere was most likely lacking free oxygen, probably consisting of carbon monoxide, carbon dioxide, water vapor, nitrogen, hydrogen, ammonia, and methane. Complex molecules and primitive organisms would have difficulty forming with free oxygen there to burn them up by oxidizing them. Yet, the electromagnetism of atomic structures enabled many energy exchanges and combinations to develop. Without an ozone shield in the atmosphere, ultraviolet radiation from the sun would disrupt the genetic mechanism of anything that might be exposed on land. Yet, the radiation could release hydrogen from water that could be used as energy for an organic process in a molecule that might thus come to resemble bacteria by a photosynthesis that did not produce free oxygen. Radio astronomers have discovered evidence of several organic molecules in outer space. The structural pattern of the mineral kingdom had been established when about 4 billion years ago a process began that would enable physical entities to take in energy, grow, replicate themselves, and even evolve the genetic pattern of replication. Because of their ability to give and take electrons, hydrogen, oxygen, nitrogen, and carbon became the building blocks, along with elements such as phosphorus, calcium, and sulfur for energy exchange. Stimulated by solar radiation and somewhat protected underwater, these elements formed into amino acids, which combined together with peptide bonds eventually to become proteins. Self-replication requires an information system, and in this case, a molecular code was used deoxyribonucleic acid, DNA, and ribonucleic acid, RNA, to communicate the basic chemical design of the various protein-building amino acids. These cellular messengers use 4 basic molecules as letters linked in chains of 3-letter words as a complex grammar of instructions for physical bodies to build and organize themselves intelligently. To grow, the first organisms needed energy, or food. At first, the energy of solar radiation was used in a photosynthesis that did not produce free oxygen. Early cells, such as bacteria and blue-green algae, reproduced themselves simply by dividing in 2. Yet the high-energy ultraviolet radiation of the time could cause numerous mutations, some of which proved to be improvements in cell structure. As bacteria, algae developed photosynthesis that does release free oxygen, then oxygen and ozone shielding began to build up in the atmosphere, lessening mutations from radiation. At this stage, sexual reproduction involving the pairing of chromosomes and the division of reproductive cells through meiosis enhanced variability and the evolutionary process of natural selection. This development of eukaryotic cells was probably reached between 1 and 2 billion years ago and is considered the beginning of organic evolution. Complex molecules had been organized into units bound by a protective membrane through which they could take in energy and nourishment and release waste. Prokaryotic bacteria and blue-green algae never evolved cellular nuclei nor sexual reproduction and are the same today. Through photosynthesis, oxygen eventually built up to its current concentration of about 21% of the atmosphere, which is a homeostatic balance between optimum metabolism and fire risk. Some bacteria began to use this oxygen for energy and evolved to become animals. Single-cell organisms, which produce by division, are potentially immortal and thus static. By developing germ cells of 2 types that could recombine, sexual reproduction created variability and interaction. Large germ cells, eggs, containing food materials could unite with small germ cells, sperms, consisting of a nucleus that could move well. However, unicellular organisms could only grow so big because volume increases faster than surface area, thus limiting the food they could absorb. About 700 million years ago, these cells began to clump together in groups or communities in order to produce larger and more complex systems, as sponges. This evolutionary step of group cooperation enabled cells to specialize and contribute to the whole organism by serving as protecting casing, digesting of food, and eventually sensing and conveying messages. Now that germ cells could reproduce a similar but not identical organism, that meant that the old organism would eventually be eaten or decomposed by bacteria, fungi, and viruses, and therefore die, having been replaced by its new but slightly different offspring. Roughly 500 million years ago, vegetation began to colonize the land, first as mosses and liverworts, and then developing into vascular plants. Since vegetation needs only sunlight, water, and carbon dioxide, plants are not required to move from place to place searching for food. Thus, they drew nourishment in water or rooted in the ground wherever sunshine was present. Animals evolved the ability to move with a mouth in front and waste disposal in back. Successful mutations and variable reproduction evolved organs of sensing to assist the organisms in finding food. These sense organs and their communication system naturally centered in the brain at the head of the organism. Hard bone cells were found to give protection to the main line of the nervous system and strength to the organism's structure. Thus, vertebrates and fish evolved. With more genetic experimentation, mutated flippers and fins were used to push on the ground in shallow water. And eventually legs and amphibians evolved who crawled onto the land about 400 million years ago. Amphibians depended on water to nurture the growth of their embryos. After about 100 million years or so, the shelled egg was evolved by the first reptiles, enabling them to stay on the land permanently. Reptiles primarily ate insects, which were living off the abundant vegetation. Eventually, some reptiles became herbivorous, eating tropical plants in aquatic environments. Reptiles were very successful and grew in size. As much of the land dried out, reptiles took prominence over the amphibians. For well over 100 million years, dinosaurs dominated the earth. Although some of them may have been warm-blooded, it seems that climatic change and temperature extremes may have led to the extinction of the larger reptiles about 60 million years ago, while crocodiles survived in tropical rivers and the smaller snakes, turtles, and lizards managed to survive by burrowing or crawling into holes. Even the large squid-like ammonites that lived in the sea died out at this time. Apparently, large size, even with ferocity, was a liability in adapting to the winter cold and summer heat. Birds and mammals evolved ways to stabilize their internal temperature. Birds used feathers to keep warm and wings to escape predators and search for food. Mammals evolved fur to keep warm, milk glands to feed their young, and large brains for skillful adaptability. Warm-blooded species have physiological mechanisms to circulate heat and cool off in hot conditions, enabling them to survive cold nights and warm days. With the decline of the dinosaurs, the primitive mammals began to flourish and evolve more complex forms to fill the ecological niches now available. The remarkable evolution of flowers, fruit, nuts, and grasses at this time improved the food supply for animals. This stimulated early primates to evolve grasping hands, generalized teeth, stereoscopic color vision, and a still larger brain for the climbing of trees and other skills. The spiritual view is that all of this creation and evolution occurs within the consciousness of God according to the divine plan. Spirit pervades all of the creation by extending itself invisibly into stars, planets, and living organisms. Evolution is the process by which Spirit creates opportunities for learning and spiritual growth that are gradual to various levels of consciousness. What can we learn from this evolutionary process? Obviously, life is not static, but moves. And it moves in a direction of improvement toward greater awareness and capabilities. In these continual changes, we need not become too attached to a particular form, because it is likely that we will outgrow it or use something better in the future. Adaptability to the environment is the key to survival and success in this world. The Earth has a long history, and our little epoch of recorded history is just a brief moment in the lifespan of the Earth. Yet the Earth is our home, and not having learned how to live anywhere else permanently, we need to preserve the health and ecological balances of the living Earth, Gaia. We are just one creature living on the Earth's body, and we ought to respect the others, especially whales, dolphins, and other mammals whose experiences are of great spiritual value to the conscious entities that inhabit those forms. How can we ever measure the gratitude we owe to this wonderful and beautiful place where we have been growing toward conscious godhood? Where would we be if it hadn't been for all our ancestors and the Earth itself? Human evolution. Before continuing the story of evolution with the primates, let us consider their consciousness so far so that we can understand some of the basic instincts and motivations that all humans still share, even though we may have been modified greatly since then. Certainly we can see that all life forms that have survived to pass on their characteristics to their descendants have very strong survival and reproductive instincts. For primates, surviving means being able to function as a living organism by breathing air for energy, regulating the body's temperature by drinking water, finding and eating and digesting food for physical energy, and being able to escape danger and early death from predators. While the internal physiological mechanisms seem to be mostly automatic and unconscious, the abilities to find nourishment and avoid danger are more conscious activities. because they involve interaction with the outer environment by means of sensory perceptions and skilled actions. The early primates, which later evolved into monkeys, apes, gorillas, chimpanzees, and humans, began small, like rodents. When the earth was mostly covered with forests, they were able to live in trees by using their grasping limbs and digits and stereoscopic color vision. Their brains were large enough to give them dexterity in climbing, seeing food, grasping it, and avoiding dangers. Their diet of leaves, flowers, fruit, insects, birds' eggs, and possibly nesting birds did not require the specialized teeth found in most mammals. Possibly the primates' taste for dinosaur eggs may have contributed to the extinction of the large reptiles. In the trees, vision became a more important sense than smell, which is so well developed in other mammals. The process of adapting to climbing trees and jumping from branch to branch must have resulted in many casualties and deaths for those primates which fell to the ground. This survival of the fittest evolved more brain capacity for vision and muscle coordination. In this environment that was less predictable than solid ground, those that learned how to be careful and skillful survived. The ability to grasp the branches with the feet and what came to be hands was naturally selected. Upright posture also became preferable, and the skeletons began to change so that the backbone was more vertical and the neck redirected in order to balance the skull above it instead of projecting the head forward as with four-legged animals. The arms were able to swing more freely, as those primates who could swing from branch to branch had an advantage. The thumb began to oppose the other fingers for good gripping, and the skins of the finger pads became very sensitive. The nose became smaller and the eyes larger and more sensitive to light. With two eyes facing forward, taking in an overlapping field of vision, primates developed sharp depth perception. The brain became larger even faster than the size of primates themselves increased. This implies that they were probably much like contemporary chimpanzees and apes, which are primarily social and communicate with each other. Sounds could be made to warn others of dangers or to express jealousy or displeasure. The need to reproduce certainly made the sexual instinct quite strong. Also, since the offspring must survive to reproduce themselves, the maternal instinct to care for the next generation was also selected. As the brain began to grow more after birth, since the size of the birth canal was limited, the period of helpless infancy and early learning through play was extended. The genes of humans and chimpanzees, our closest biological relative, are about 98% the same. It is estimated that our evolution only began to diverge about 8 million years ago. Our ape-like common ancestor called Ramapithecus lived in Africa and parts of Europe and Asia between 15 and 8 million years ago. As they began to use their hands more for defense, the need for large canine teeth diminished. During this time, the amount of forest declined, creating open savannas. In this environment, the ability to stand up and look around was quite useful for finding food and perceiving predators. Walking on two legs, these primates could carry food or their young in their arms. The ability to grasp objects in their hands enabled Ramapithecines the opportunity to extend their bodies by picking up a branch or rock and brandishing it to scare off a predator. Eventually, objects were used as tools to assist them in digging for roots or catching insects or for fighting off predators. Naturally, the improved vision and mental adaptability learned in the trees was helpful on the savanna as well. During a period of about 10 million years, when declining rainfall and increasing deserts separated the forests of Africa from those of India and East Asia, the shrinking living space for the Ramapithecines must have caused the estimated 20 million hominids to become more social in the 300,000 or so bands. By 4 million years ago, what is now called Australopithecus, meaning southern ape, was walking fully erect such that the feet were no longer able to cling to branches or the fur of the mother. Such infants required even more care and attention. Australopithecus stood about 4 feet tall, and the brain was still fairly small compared to Homo sapiens, gradually increasing from 400 cubic centimeters to 700 for the tool using Homo habilis by 1 million years ago. Apparently, between 2.6 and 2.3 million years ago, there was a cold and dry period which stimulated greater adaptability. The earliest tools have been found from this time and probably consisted primarily of sticks and stones, which were flaked to make choppers, scrapers, gougers, and hammers. Anthropologists theorized that on the savanna the social organization of the family developed, and perhaps also hierarchies of dominance, with the males, females, and young sequenced in that order according to individual strengths. Australopithecines began to eat the meat of dead animals that they were able to find or steal away from other predators. Eventually, they began to hunt live animals for themselves, probably acting in bands of mostly males. At this time, the males were about twice the size of the females. And as the hips became wider in the females for a wider birth canal, the males could also run faster. At first, the hunters only attacked small game such as birds, lizards, rats, hares, tortoises, and young antelopes. This change to meat eating is a major shift in human evolution. For more than 100 million years, primates had been vegetarians and insect eaters. They did not have the specialized teeth of carnivores for ripping and tearing flesh. Their long digestive tract is designed for plant food, whereas carnivores have short digestive tracts which eliminate the meat residue out of the system more quickly. Humans still have difficulty digesting excessive amounts of animal fats. However, Australopithecus was able to survive by eating red meat, although this certainly put them in enmity against many other animals. Tools were probably developed to enable them to tear through the tough hide of young antelopes and to smash open the bones to get at the marrow. Hunters had to be able to scare off scavengers such as hyenas, jackals, and vultures, and probably carried their meat into trees or rock shelters. Gradual evolution from Australopithecus results in a Homo erectus who was about 5 feet tall 1.6 million years ago. And by 1 million years ago, the brain has grown to an average of nearly 1,000 cubic centimeters. Females are closer in size to the males. These early homos spread north out of Africa and Southeast Asia into Europe and China about 700,000 years ago. Toolkits began to contain hand axes. With the wide variation in brain size, the experience of hunting and traveling over large areas selected rather rapidly for larger brains with more skill and memory capacity. Successful hunting requires patience, sensitivity of perception, communication, and group cooperation. Homo erectus is the first primate to share food regularly with other adults. Hunting surely alienated homos from other large animals, as the act of brutal killing selected individuals with this aggressive instinct. Yet, the complex planning and teamwork involved in hunting also stimulated and selected intelligence, if not compassion for other animals. As the brains became larger, the infants developed more slowly, requiring up to 5 years of parental care. Primate evolution had also moved away from litters of offspring and towards single births, until now it is rare for a woman to have more than one child at a time. This allowed for greater prenatal growth and more special care from the mother after birth. As the infants required more care from the mothers needed more protection and help from a reliable male. As the male went off bonding together as hunting parties, the females were able to gather plants locally and prepare food, bonding with their children and each other at home. Homo erectus is the only mammal in which the estrus period of procreation has completely disappeared, so that the female is not preoccupied by periods of intensive male sexual attention, which would be disastrous for the infants, but instead is attractive to the male at any time. Also, the erect posture allows humans to copulate face to face. Thus, the sexual act became less mechanical, quick, and instinctive, and more likely to be an emotional experience. As the brain and intelligence increased, thought, feelings, and choice became more available to early humans. In other words, voluntary control of these instincts developed so that the individual could choose the partner and the time and place for sexual intercourse. As personal preference became more meaningful, male-female relationships could become more enduring. Also, as sexual activity could be chosen for its pleasurable qualities, homosexuality became possible. The ability to plan and think and restrain oneself while hunting prey affected other activities as well. Inhibitions and prohibitions regarding sex developed for social reasons, as dominant males expressed jealousy and prevented promiscuous relationships. Concern that the young become socially mature as well as sexually mature before producing children may have led to incest taboos and delayed mating until the male was ready to provide for a family. As different groups hunted in competition with each other, ways to avoid violent and deadly conflicts between groups may have developed, such as mating with members of other groups to develop emotional ties. The first use of fire seems to coincide with the movement of early humans north into China and Europe. Fire could be obtained first from lightning strikes or burning oil from the ground and could be kept carefully burning. Eventually, means were developed to light fires. Fire gave humans more independence and made them considerably more threatening to other animals. With fire, they could scare large predators out of caves and take them over for homes. Fire gave them light as well as warmth so that they could socialize and communicate more at night. Fire also assisted tool making by sharpening spear points and so on. Cooking improved the taste and eased the digestion of many foods, especially starches. Softer foods put less strain on the jaw muscles, which gradually decreased along with the molar teeth. These changes accompanied a thinning of the skull bones, allowing for the selection of still larger brains. By 300,000 years ago, Homo sapiens was hunting game as big as elephants and beginning to emerge with an average brain size of about 1,100 cubic centimeters. And by about 100,000 years ago, the current average of 1450 was reached. Certainly, the use of fire made humans more domestic as they patiently prepared or waited for the cooked meals in their warm homes. As hunters developed signals into better communication and returned to the family hearth, the urge to share their experiences with their families must have stimulated the development of language and storytelling. The women surely also invented terms or verbal expressions to indicate objects and activities. With small teeth and an agile tongue, many different sounds could be made and distinguished by their excellent hearing. As memory increased, older members of the families were valued for what they could tell of the past and earlier traditions. Knowledge and skills could be passed on from one generation to another. Fire is also a powerful symbol and could have been used in various rituals at night to enhance social cohesion and pass on traditions of hunting and other important activities. What have been called Neanderthals lived between 100,000 and 35,000 years ago. Although only about an average of 5 feet tall, their brains were a little larger than modern humans. Found mostly in Europe, they lived well into the last ice age, which began about 60,000 years ago and lasted until about 11,000 years ago. The need for vitamin D in the northern climates probably selected for whiter skin, which could absorb it better than from sunlight to prevent rickets, of which many died. Neanderthals are the first creatures known to have buried their dead. Evidence indicates that 60,000 years ago, a man was buried on a bed of flowers accompanied by a wreath of flowers. Other graves were surrounded by a circle of stones or goat skulls. Remains of an amputee and an arthritic man have been found, indicating that they cared for their disabled. Other evidence reveals that individuals may have been killed by weapons or had their brains eaten. Their tools became lighter and more artistic, but they continued to hunt large game, such as mammoths. About 35,000 years ago, a transition occurred to the anatomically modern human called Cro-Magnon. They began to follow the herds of reindeer, bison, mammoths, and horses they ate. And tools became even more sophisticated, using bone, antler, or a wooden tool to press off small flakes from a flint core. The stone burin tool was used to carve bone and antler into harpoons and fish hooks as humans began to eat seafood. The atlatl, or spear thrower, was invented and more than doubled the distance a short spear could be thrown. Even more effective was the bow and arrow, invented about 20,000 years ago. By then, fish traps were used to catch salmon in Western Europe. Social organization advanced as bands joined together to form tribes. Long houses were built for a community of several families. Incest taboos and kinship rules, no doubt, were quite complex. Cooperative hunting on a large scale may have occasionally led to warfare between such tribes. Bone needles found as far back as 20,000 years ago indicate that clothing from animal skins was increasingly used. The massive ice at this time must have lowered sea levels by 250 to 500 feet, exposing vastly larger areas of continental shelf. The human population of perhaps 10 million spread throughout the world, including to America and Australia. Tools and weapons were decorated with engravings of animal figures. Pigments were used for cosmetics, and decorative jewelry such as pendants were worn. Female figurines were designed out of bone and ivory, and eventually these figures, emphasizing female characteristics, were shaped out of clay. Inside caves, paintings of animals were made. Some deep inside the caves were very skilled and were probably used for mysterious hunting rituals. In order to do such painting, oil lamps must have been invented. This art reached its height when the herds began to decline, but the painting was discontinued about 12,000 years ago. As the last ice age receded and the climate warmed up, the old hunting lifestyle seemed to change. As human population increased while the available animals for hunting decreased, new sources of food had to be found. Experiments with the cultivation of plants were to lead to a new way of life and a new form of human culture. Although we don't have specific events to evaluate, by now morality had become an important human concern. We can hardly judge the early primates for causing the extinction of dinosaurs by eating their eggs, for they were merely following the instinct to survive with little or no awareness of the consequences of their actions. Yet, sometime between then and the beginning of religion, as indicated in burial customs and art, enough consciousness had developed to make individuals responsible for their actions. When is the origin of ethics? Is it when hominids were intelligent enough to use tools and could consciously kill another of their own kind? Is it when they could control their sexual urges enough to make a choice as to their partner? Is it when they felt responsible for the raising of their offspring? Is it when they depended on the cooperation of others in their band? From the spiritual perspective, the soul is responsible. When the soul enters into an animal body that is evolved enough to offer it a valuable experience, the consciousness of right and wrong inevitably results from the awareness of choices. When we are consciously able to choose, we are attempting to choose the good and avoid the bad. As the brains of the early humans became large enough to give them this awareness, then ethics had begun. And I believe that this may have coincided with the beginning of souls embodying themselves in human form. What then was the ethics of the hunting and gathering cultures? Certainly the violence of killing animals to eat their meat not only increased aggressive tendencies by natural selection, but also became a socially acceptable way of behaving. For more than 1 million years, humans were brutally killing other mammals for the sake of survival. However, there is only a little evidence that they were killing each other. Murder, war, and cannibalism, though they did occur, did not seem to be common then. As with most other mammals and so-called primitive peoples, conflicts over territory or sexual possession could usually be resolved by threats and often ritualistic confrontations that determined without violence who would prevail. Although these incidents probably did result in some hierarchical social structures, studies of hunting and gathering cultures tend to show that members of the same band cooperate by sharing their resources and looking out for each other. Before the development of private property, people seemed to function more as a unified group. Wealth was not hoarded by some while others were left to starve or forced into slavery because there was no wealth to hoard. Systems of kinship governed sexual relations with taboos and various patterns of exogamy and endogamy. Family became important and eventually extended to more distant relations in the clan. Ironically, the aggressive instinct of hunting was not turned against other humans much until agriculture made hunting unnecessary, but produced wealth and social hierarchies, both of which eventually led to organized warfare. Lemuria and Atlantis. Myths and legends from many different cultures refer to very ancient continents and their cultures that may have existed long before recorded history. The most prevalent of these are about Atlantis, which is said to have been in the Atlantic Ocean more than 10,000 years ago. However, long before that, esoteric tradition tells of a large continent in the Pacific Ocean area called Lemuria. In oral traditions, much can be indicated from names. Lemurs, like humans, are primates, and they live in trees. Since Lemuria is considered the most ancient place where early humans lived, it might correlate with the Ramapithecus, who are living in trees in a warm climate with abundant fruit and nuts, a veritable paradise without much knowledge of good and evil or self-consciousness. Some have placed the Garden of Eden in Lemuria. Perhaps the fall of man symbolically refers to the change in climate that started about 2.6 million years ago in the time of Australopithecus and led to meat-eating, hunting, and killing. Although many clairvoyants and esotericists have described previous lifetimes for individuals in Lemuria or Atlantis, probably the psychic with the best overall record is Edgar Cayce, 1877 to 1945. As I do not intend to try to prove anything in this discussion, I shall limit the psychic evidence primarily to Cayce's readings so that at least the esoteric view can be considered. The Cayce readings refer to human evolution as the gradual growth toward the mind of the Maker. All souls were created in the beginning and are finding their way back to whence they came. The Cayce readings state that humans appeared on the earth 10.5 million years ago and refer to projections from the animal kingdom. These took on many sizes as to stature, from midgets to giants, for there were giants in the earth in those days, men as tall as 10 to 12 feet and well proportioned throughout. I find this particularly interesting because it matches the description given of my first embodiment by the clairvoyant John Roger when he told me that I incarnated in a body that was about 12 feet tall. When I asked him if that was during the time of Atlantis, he said it was much further back. When I asked if it was during Lemuria, he said at first much further back again, but then said Lemuria was in existence at that time. According to Cayce, early Lemurian development began about 1 million years ago. It was inundated by water and its people scattered 500,000 years ago. Then it was inhabited and its civilization advanced between 400,000 and 300,000 years ago. A second Lemurian catastrophe occurred 250,000 years ago, possibly by fire. Numerous Cayce readings refer to Atlantis, which is said to have emerged about 200,000 years ago, which would correlate with the beginning of a major ice age. As the levels of the ocean declined, much of the shallow continental shelf in the Atlantic could have emerged. The Cayce readings also refer to major events occurring about 50,700 BC. First, there was a world conference of experts to decide what to do about a problem with large animals. Apparently, the methods chosen to deal with it using fire and perhaps natural gas from underground led to the first major catastrophe for Atlantis, perhaps the final destruction of Lemuria and the onset of another ice age. Casey readings declare that the second period of cataclysms for Atlantis was about 28,000 BC and caused the already broken up continent to sink with the exception of a few islands. This catastrophe is said to be the origin of the biblical flood and the deluge myths of other cultures. This seems to correlate with a major interstitial melting of the ice in the middle of the last ice age. However, the final destruction of Atlantis is dated by Casey as 10,600 BC and correlates with the end of the last ice age, which also could have been the source of many deluge legends. Casey describes influences on the people in the Pyrenees and the sending out of colonies by those who foresaw the destruction to Egypt and Yucatan, where they built pyramids. The Incas are said to have been influenced by Lemuria. Interestingly enough, a map of the most advanced sites involving Cro-Magnon shows a concentration on the Atlantic coasts of Western Europe and along the rivers that empty into the Atlantic Ocean. Later, during the Neolithic period, the megalithic tombs and temples, such as at Stonehenge, were likewise concentrated on the western coasts of Europe, England, and Ireland. The Casey readings tell many stories about Atlantean and Egyptian culture and the spiritual conflict between those who followed the law of one versus the sons of Belial, who were more selfish and exploited animalistic people. Most difficult to reconcile are the descriptions of the advanced technologies of Atlantis that include virtually all our modern inventions, including airplanes, submarines, radio, television, atomic power, lasers, and even solar energies that we haven't yet developed. Given the large gap between this and the level of technology so far uncovered by archaeologists for that period, it is difficult to believe these at this time, though perhaps eventually evidence will be found. The oldest texts referring directly to Atlantis are by Plato, 428 to 348 BC, in the Timaeus and Critias. In those dialogues, Critias gives an account he heard when he was only 10 from his 90-year-old grandfather, who heard it from his father, who got it from Solon, who heard it from priests in Egypt. Critias admits his account is unusual, but declares more than once that it is not a myth, but true. Solon, who lived from 638 to 539 BC, was so impressed with this story that he was going to write an epic poem about it, but was unable to complete it. The Egyptians chide Solon and the Greeks for being so young culturally with little memory of the ancient times. For you remember but one deluge, though many had occurred previously. The Egyptians claim that their civilization is 8,000 years old, and that the Atlanteans were 9,000 years before the Egyptian record. The continent of Atlantis was beyond the Pillars of Heracles, which is the Straits of Gibraltar, and was larger than Libya, which is Africa, and Asia together, dwarfing in size the Mediterranean area. The kings of Atlantis ruled over many islands, and Europe as far as Tuscany, and over Libya as far as Egypt. Solon, who was a great lawmaker in Athens, tells a story in which Athenians are battling against the Atlanteans who have become oppressive. However, portentous earthquakes and floods swallowed them all up in one day, and the mud the island created as it settled blocked up their passageway to the ocean. Solon associates Poseidon, the god of the sea, horses, and earthquakes, with Atlantis, and says that his son, Atlas, was the first king and ruled along with 10 of his brothers and their descendants. His account also credits Atlantis with being wealthy and as technologically sophisticated as their own culture in using metals, chariots, and sailing ships. However, their destruction is brought about by the loss of divine qualities and virtue as they succumb to greed and ambition. Zeus, the god of the gods, is about to give a speech calling for the punishment of the Atlanteans when the dialogue by Plato is abruptly cut off unfinished. Like Casey, Plato gives us an account of an advanced culture that is destroyed because of its spiritual and moral failures. The other main classical source on Atlantis is the general history written by Diodorus Siculus in the 1st century BC. This Hellenistic historian describes the Atlanteans as living in the regions on the edge of the ocean. Their reputation excels their neighbors in reverence towards the gods and in humanity towards strangers. The Atlanteans claimed that the gods were born among them, and Homer is quoted in the Iliad where he said he went to the ends of the earth to Okeanos, the origin of the gods. Diodorus then describes the myth of their first king, Uranus, Gai, Basileia, Rhea, Hyperion, Helios, Selene, Cybele, Marsyas, Dionysus, Apollo, Kronos, and Atlas, whose 7 daughters are associated with the stars of the Pleiades. The Olympian Zeus, whom he differentiates from the Zeus who was born of Crete, who was king of Crete and brother of Uranus, overthrew his father Kronos and the Titans. Gaining supreme power, Zeus traveled all over the inhabited world, doing good for the masses of people while punishing the evil. After he passed on, his name was associated with the word living, and he was enthroned in the heavens as God of the whole universe. This account by Diodorus, though to be treated with skepticism, nevertheless does explain why the gods and goddesses of Greek mythology may have had such human characteristics in their romances, jealousies, and fighting with each other. Agriculture. Although cereals were being harvested with flint-bladed sickles and ground by limestone in the Nile Valley more than 15,000 years ago, plants and animals were not domesticated for food until about 10,000 years ago in the Fertile Crescent of southwestern Asia, and soon after that in Mesoamerica, Peru, and China. While the ice was melting and the climate was warming up, the reindeer and horses retreated to the north, and the mammoths disappeared. Forests spread, and those animals were replaced by red deer, wild pigs, and cattle. Dogs had already been domesticated for a few thousand years. Sedentary communities settled down in Southwest Asia about 1,000 years before wheat and barley were domesticated, supported by herds of wild sheep, goats, cattle, and pigs, which were all domesticated by 6,000 BC. Maize, which we call corn, beans, and squash were cultivated in the Americas, and Asia thrived on rice and millet. Women were probably responsible for learning how to cultivate plants, as they seem to have done most of the plant gathering. Women also probably invented potting, spinning, and weaving. Men, used to hunting, probably took care of the herds, and after the plow was invented, castrated bulls to use oxen to pull plows and carts, though a Sumerian poem refers to a woman in the fields with the plow. Dugout canoes were used for fishing and as transportation for trading such items as obsidian, shells, salt, food, and clothing. As more farmland was needed, the invention of the axe enabled people to cut down trees and use wood for building houses. At first, houses were round, like the communal caves and huts, but soon rectangles were used so that additional rooms could be added. In such villages, the family replaced the band as the basic social group. The oldest city discovered so far is Jericho, which had 2,000 people between 8350 and 7350 BC. A large stone wall surrounded the settlement. In the Zagros Mountains, people living at Ali Kosh hunted gazelles, wild asses, and pigs, fished in the Meme River, and caught wild fowl about 7500 BC. Soon they were growing two-roed barley and emmer wheat. Between 6250 and 5400 BC, Satal Huyuk in the Taurus Mountains of Anatolia had a population of about 5,000. Numerous bull skulls and horns found in the houses indicate that people probably engaged in rituals as families. Corpses were put out somewhere to be picked clean by vultures before their bones were buried under the floor in their houses. The simplicity of most grave objects indicates that this society was probably fairly egalitarian. pottery vessels, which have been found in Japan as old as 12,000 BC, became widespread in the Near East by 6500 BC.